to my YouTube channel. If you're a data analyst or a data scientist, there's one thing you must know, and that thing is you cannot actually perform a good analysis or build a good model without performing a thorough data cleaning. So if you go to my YouTube channel, you'll see that for the past weeks, I've been concentrating on data cleaning. Why? I had an interaction with a couple of entry-level data analysts, and I found out that one of the major issues or one of the major challenges they're facing is how to perform a thorough data cleaning. So in these coming weeks, I'll be uploading a lot of video on data cleaning. So if you're looking at taking your data cleaning skill from zero to hero, I will advise you stay tuned to my YouTube channel, subscribe, like, and share. In this tutorial, we are going to be taking a messy data set and cleaning it from start to finish. So if you're looking at learning how to clean a messy data set like a pro, this video is for you. Don't forget to hit the subscribe button, like, and share. So we have already created a Python file for it in our Jupyter notebook, and we have named it the loan data cleaning tutorial, which is called the archive 28. Now, as you can see, we have already extracted this archive 38, so we can actually access it. Now, when you look at this, you can see tests and we can see train, right? Now, what is this telling you? This has to do, I think this has to do with machine learning projects where they have the test train data, the test and the train data. Like we know, train data set always has more data compared to the test data set, right? Which you actually just work with maybe 20% or 30% of the data, right? So we are not going to be making use of this particular data set. We are going to be making use of this. The first thing we have to do here is importing our necessary library. Now let's say importing libraries, importing libraries. Now when you look here, this is where you run your code, right? This is where you run your code, start writing your code. Now this is where you can change to code or markdown. So markdown is basically your text, while code is normally for writing your codes, right? Now, when you use this hash, right, in a code, right? Maybe let's say we are in the code section and we are using this hash in a code. This hash simply means comment out, right? It simply means that whatever you write after this hash will not affect or be added to your code when running your code. But in a situation when you're making use of this as a markdown, right, this hash actually stands for how bold you actually want your text to be. Now, one hash means you want the text to be bigger. While double hash, as you can see, the more we add hash, the smaller the text become, right? Now, let's go ahead and run this. Now, when you run this, you see that we have successfully written a text that says importing our libraries, right? Now, remember I told you about the commenting out using hash, right? Now, we want to import pandas, right? We want to import pandas. Now, this comment out ensures that anything you write, right, after this hash does not affect your code when you are in the code section, right? Now, when we say import pandas, then we say import pandas as PD, right? Now, you see that this successfully goes ahead to import or execute pandas, right? You see that this automatically goes ahead to actually import pandas, right? As you can see, this doesn't actually affect your code. Now let's try eliminating this hash and see what happens. When you eliminate this hash and run this now, you see that it is showing as a code, right? Let me say I say importing instead of import, right? And let me run this. As you can see, it says invalid syntax, right? But let me go ahead and add this hash and then run it again. As you can see, it works. This is the use of hash when working in Python. But let's go ahead and delete this because this is not what we want to do now. I don't really know why I'm so dehydrated today. Sorry, please, let's get back. Now, what we have to do is, since we have already created a heading that says importing libraries, right? What we have to do is import the necessary libraries we want to use. For a start, we have to import pandas as PD. Import pandas as PD. Then we also import numpy as NP. So we are not doing any visualizations, right? We are not doing any visualizations. This is just thorough data cleaning tutorial. But we can still go ahead and import visualization packages, like let's say importing Seaborn as SNS, Seaborn as SNS, right? Then we can also decide to import matplotlib, but that's not necessary. But the most important thing I want us to import is import warnings. So this actually helps us eliminate or ignore all warnings we get when writing our code. Now we can simply say warnings dot filter warnings, right? Filter warnings, and let's use ignore. Now let's go ahead and run this. Okay, this should be Seaborn, please. Now, as you can see, we have successfully run these codes, right, with no error. Now, the next thing we have to do, of course, is import our data sets, importing data sets. And let's go ahead and turn this to a markdown and run it. Now, to import data sets, we actually have to declare a variable. Now, of course, we all know if you actually use to Python, the variables we always use is VF, right? So this is just a variable. It can actually be whatever you want it to be. You can simply say checkup, right? Checkup, right? That's the name of the variable. So we can simply say checkup is equals to pd.read, right? Then we say underscore CSV because that's a CSV file. Then we can go ahead and we said we are going to use the train data set. So we can go ahead and copy the 5 parts. So we copy as parts, right? Then we can come here and do this and paste it here. Then at the back we say read. Now let's go ahead and run this, right? As you can see, whatever variable you call it, it doesn't really matter, right? It doesn't really matter. You can call it df, you can call it checkup, you can call it whatever you want to call it. So the variable doesn't really count, right? Now the next thing we have to do is let's go ahead and do our data investigation. Data investigation. Now let's run this. Now to do our data investigation, so we have when we talk about data investigation, you just have to we are trying to get more information on our data. That means exploit our data sets and know what is actually happening in the data. Now the first thing we have to do is let's look at the first 5 rows and we say checkup.head, right? Now when we run this, as you can see, this is actually our data sets. As you can see, we have different columns. We have the loan ID, we have the gender, married, dependents, education, we have self-employed, applicant income, co applicant income, loan amount term, then credit history, property area, and loan status, right? Now, one thing you need to notice when you're looking at this is the first thing you notice is the inconsistency in the column names, right? As you can see here, we are having self underscore employed, while here we are having applicant income applicant income, sorry. And here we are having loan underscore amount underscore term. And here we are having credits underscore history. Now, as you can see, there is inconsistent data column name, right? We have an inconsistent column name. So we also have to put that in mind because we are going to be changing that, right? But let's go ahead with our data investigation. Now, the next thing we have to do is let's look at the first last rows, sorry, rows, and let's do then we do sorry, what am I doing? We do checkup dot tail. Now let's run this. Now, as you can see, this gives us the first last rows, right, of our columns. Now, look at this. We can already dictate an error here. When you look at this, we are seeing 3 plus, right, which we are having a non-numerical character attached to this, right? Now, we are not handling that yet. We are leaving that, right? Now, the next thing we have to do, let's look at our statistical information. Now to do that, we say checkup dot describe. Now this gives us the statistical history of our data sets. Now let's run this. Now when you look at this properly, you can see that this is the count of each column, right? This is the count of each column, right? Now when you look at this properly, okay, before we go ahead, let's go ahead and just say df.info. There's something I would like to explain there. df.info. Now, when you look at this df.info, you can see that we have a total of 64 entries, right? Which simply means that we have a total of 64 rows, right? A total of 64 rows, and we have a total of 13 columns, right? Now, remember that now this is giving us 0 to 613. Remember that in Python, we start counting from 0, not 1. In Python, we start counting from 0, not 1, where we have our 0, 1, 2, 3, not our 1, 2, 3, right? Now, when you look at this, it simply means that we should have a total of 614 entries for each columns, correct? But now let's go to our our describe, right? When you go to our describe, this is giving you the count of each columns, right? Now, when you go to applicant income, you see that it's giving you 60, 614, 614, 592, 600, 564. Now, from this, you can simply deduce, or we can simply get to say that we have missing values in some columns, right? As you can see, the only complete columns we have in our numerical columns is our co-applicant income and our applicant income. While in our loan amount term and credit history, we are having missing values. Now, when you do 614 minus 592, 614 minus 600, 614 minus 564, it is going to give you the total amount of missing values we have in our columns. Now let's move ahead. Now, one thing you also need to know about describe is it only works with numerical columns. Now, I mentioned that describe is used to get statistical information on our data. Of course, we all know what statistics is, where we are talking about our mean, media, and everything. So the describe only works with numerical columns. Now, when you look at this, you will see that there is no categorical column here. Is because describe works with only numerical columns. Now, when you look at this, you can simply deduce also that we have some missing values in some of the columns, right? Now, when you look at this, you know we have only 1, 2, 3, 4, 5, 6 columns that are complete out of 13, right? Now, another thing you need to look at is this, the type. This simply means data type, right? Now, this is simply telling us the data type for each of our columns. As you can see, loan ID is object. Object means categorical columns, which is just like our text, our string, right? While integer, applicant's income is integer, while the rest are floats. Integer is just our numbers like 1, 2, 3, 4, 5. Float is our numbers with a decimal point, right? Like this now, this is a float, okay? Now, this is what this area is telling us about, right? But now, when you look at this, even though we are not going into this that properly now, but when you look at this properly, well, there's one thing you will notice that most of the data types are incorrect. Now, how do we know? Now, let's look at, for example, let's look at dependents, right? Now, when you go up, you see that dependent is giving us numerical. But when you come here, you see that dependent is giving us an object. That means it's telling us that is a categorical data, which is incorrect. This simply means we have to go ahead and change dependent from categorical to numerical. But we are not going into that yet. Let's move ahead. Now, the next thing we have to do is let's check for missing values. Now we say checkup dot is not dot sum. Now let's run this. Now, when you run this, this shows us that we have different missing values. We have missing values in the different columns. Now, there's a library I like importing, which I forgot to import, and I call it the missing null. So I can say from import missing null as MSNO. Now let's go ahead and run that. Now, what does missing not do? Missing not actually helps us to visualize our missing values. Now, let's go ahead and visualize our missing value, right? To do that, what we have to do is, let's say msno dot bar, right? Now, what is the name of our data frame? Checkup, right? Checkup. Now, let's go ahead and run this. Okay, let's wait for it to come up. It's loading. Now, as you can see, this has simply visualized our missing values, right? Now, look, this actually consists of each columns that we have in our data frame. Now, like we mentioned that each column should have 614 rows. Now, any column that doesn't have 614 rows, we can simply say that it has missing values. As you can see, this we have missing values here, we have missing values here, we have missing values here, we have missing values here. So this is what missing node does. It actually helps us to visualize our missing values. Okay. Now we have successfully done our data investigation, which actually helped us to draw more information on our data and understand the various problems we have in our data. Now we have to go ahead to our data cleaning. Now let's say markdown and run. Now, the first thing we have to work on is handling inconsistent column names, right? Now, to do that, let's go ahead and say checking columns. And let's go ahead and say checkup dot columns. Let's run this. We have to go ahead and rename these columns, right? Now, to do that, we just create a new cell, of course, and we simply go ahead and say checkup.rename, right? So we specify the columns. So this is columns equals to, now let's say applicants. To avoid errors, let's just go ahead and copy this. So let's say applicant info, be applicant income, please. So let's say applicant income, all right? Then new would be applicant income, then underscore, right? Then the next one would be co-applicant income. So co-applicant income, then we say, say new co-applicants, control V, co-applicants income, co-applicants, this should be co-applicant underscore income, right? Then the next one should be loan amounts. Then we'll say loan amount. Okay, loan amount, then new loan amount. Then volumes equals to have to put our dictionary here. And let's run this to see. Okay, now if you see, we actually made a mistake here. Say on the score. Now let's run this again. Loan applicant income or applicant income loan. Yeah. So as you can see, we have actually successfully changed our data type, correct? Now the next thing we have to do is we have to go ahead and handle missing values. Handling missing values, right? Now, in this marathon, we are going to be handling missing values using various methods. But for this particular project, we are going to be handling missing values using a backfill and a forward fill method, right? Now, before we go ahead, let's create column here and let's say checkup underscore checkup dot is null dot sum. Let's run this. Now, this is showing us the various columns that actually have missing values. This is to enable us know the columns we are actually handling missing values for, right? Now, to start with, let's go ahead and say have to handle for gender. So let's say tech up. Now, this should be dot bfill, right? Now, we also go ahead to, let's just copy this, right? And let's just paste this here, right? Then we can simply go ahead and change this to married. Let's say married. Now that should be the second one. So we say married here, okay? Then we also say married here, right? Then we can also go ahead and copy this and take it to the next line. And we copy out dependents. And we say dependents. We say dependents. Then we can also go ahead and copy this and paste it here. And let's say we have missing values for self-employed too. Self-employed. Now we say self-employed. Then we also say self-employed. Then let's just simply use FU here, forward fill method. Then we can simply copy this and let's paste it. And the next one we have is for loan amount. So this is loan amount. So we paste this here. Then we also paste it here. You can simply go ahead again and copy this, right? Then we can go ahead and paste this here. Now there's something I'm noticing. I thought we actually changed all those columns. So why are they not reflecting after we changed them, right? You can see here that we changed all these columns. They were reflecting here. So why are they not reflecting, right, after changing them? Now let's go ahead and do something. Let's copy this. Now let's go ahead and delete this. Now let's run this, right? Now let's paste this. So I see takeoff dot rename applicants, okay, loan amount. So let's run this. Now let's see check results. Let's say checking results. We say let's say checkup dot columns. Let's run this. Now this is not reflecting. It simply means we are doing something wrong. So we have to go back and handle that. So even if it is showing us it's reflected here, but it is actually not reflecting. Now let's go ahead and please handle that, right? So now let's go ahead and check what we are doing wrong. Why is this code looking perfect to me? But I feel like there's one thing we are missing, and that is our in place, say as this equals to 1, as this equals to 1, in place equals to true. Now let's add that and see what happens. Now let's run this. Now it's still giving us an error. Cannot specify both as is an any index of columns and index of columns. Okay, now let's just use in place equals to true and say in place equals to true, right? Now let's go ahead and Go ahead and check for results again and see. Check results. Now let's say check up dot columns. Now let's run this. Saying invalid, invalid syntax. Okay, you see what I told you about commenting now? Look, now we have successfully corrected that, right? Now let's go ahead and just run all. Okay, now we have to just go ahead and correct it. Then loan amount, right? So the next thing we have to handle is loan amount term. So loan amount term, then loan amount term. Then we also have for credit, right? We copy this and we'll paste it here. Also have for credit history. I think that's the last we have with missing values. So we go here and say credit history and credit history, right? Now, the next thing we have to do is let's go ahead and run this, right? And just delete this, double D, then delete this. Now let's go ahead and check for results. Check result. Now let's say DF, sorry, check options. It's not. I'm sorry, Siri, I wasn't talking to you. But it's not dot sum. Now let's go ahead and run this. Okay. So why are we still having one missing value for loan amount? Why are we still having one missing value for loan amount? Now let's change this to be few, right? And let's run all cells. Oh, it simply means that we have successfully handled all our missing values, right? We have successfully handled all our missing values. Now, the next thing we have to do is changing appropriate data types, right? Now, to do that, let's go ahead and say checkup.info. Now, let's run this. Now, when you check this, you can see we have loan ID. But before that, let's go ahead and do something. I want us to check the df.head, so we can always mistaken it because I'm used to df. So checkup.head, of course. Let's run this so we can see what we are doing. So this loan ID object, it is correct because we have an letters before the code or whatever. Then gender, correct. Object, yes. The married object, correct. Dependent object, incorrect. This has to be an integer. Then education object, this is correct, right? Self-employed, correct. Applicant income, correct. Co-applicant income float, correct. Then loan amount float, correct. Then loan amount term float, correct. Then credit history float, correct. Property area, okay, object, correct. Then loan status, object, correct. Now, as you can see that the only thing we actually have to do is go ahead and change our dependents from object to integer, right? From object to integer. So to do that, what we have to do is, let's go ahead and say change, change dependents from objects to int. to integer, okay. Now what we have to do is, to do that, we say take up dependence. I know that we are going to encounter an error here, right? But I am purposely going ahead with this to show you the error we are going to be encountering. And after showing you the error we are going to be encountering, I would also like to draw your memory back to a tutorial we worked on, all right, on Power BI. So let's say this is equals to take up, then dependence, then dot as type int. Now let's run this. Boom. Now this is the error we are encountering. This is the error we are encountering. Now, if you remember at the beginning of this tutorial, I already showed you this error. I already told you that this is a data cleaning we actually have to do. Now, I want to draw your memory back. In the last Power BI tutorial we uploaded, where we did a thorough cleaning using Power Query Editor before going into building our dashboard, right? You can remember we encountered a similar challenge to this, where we were actually trying to change our data type to the appropriate data type, but we encountered an error because of we have non-numerical characters. Now, and we also handled it using replace values. Now, this is the same challenge we are encountering here, and we are also going to be handling it using dot replace in Python. Now, let's just go ahead and create another code here, and let's say eliminating non-numerical characters and changing data type. Now, before we go there, I want us to create another code so you see what we are trying to handle. So let's say value count. So you can use this using dot value count, or you can also do this using unique. So we can simply say take up, then let's say dependent, right? Then this should be dot value underscore counts, right? Now let's run this. Now when we run this, you see that this is actually what is giving us that error, this 3 plus, right? Because Python is dictating this plus as a non-numeric character, right? Just like the same challenge we had in Power BI, right? So we have to eliminate this, right? We have to eliminate this plus sign using dot replace before we can actually go ahead to change to integer. Now to do that, we say take up pendants is equals to take up dependence, then dot rename, dot replace space, right? Then, so what are we replacing? We are replacing 3 plus with 3. So we are replacing 3 plus with 3. Then we can then go ahead and change data type. Okay, then in that way we can simply copy this code here. Then we'll, oh no, so what did I do? I simply copy this code here, then paste it. Right? Now let's go ahead and run this. Okay, let's go ahead and run this. Now, as you can see, we can go ahead and delete this now. As you can see, we have successfully changed the data type, right? But let's go ahead and confirm result. Confirm result, right? Now, the next thing we have to do is confirming results. We just do checkup.info. Now let's go ahead and run this. So when you go ahead and run this, let's look for dependents. As you can see, we have successfully changed the data type of dependent, right? Now, we have successfully handled our missing value, right? And we have also successfully changed our column names, right? Okay, and we have also seen how non-numerical characters can actually pose as a problem when we are trying to change our data type, right? Now, the next thing we have to do is handling visualizing and handling outliers. Now let's say handling outliers. Now let's go ahead and make this a markdown and let's run this. Now, but before we go ahead to handle outliers, we first have to extract our numerical and categorical columns. Now, when we are talking about outliers, outliers only affect our numerical columns, right? So we have to extract our categorical and numerical columns, and we use that using the select, all right? The type dot select dot the types. Now to do that, let's say let's call our numerical column numerical underscore columns. So this will be equals to, sorry, I'm trying to remember the code. Num underscore columns. This should be equals to sec sec up dot select underscore the types. Then so select underscore the types. Then we say include should be equals to, trying to remember the code and I hope it's correct. Include should be equals to objects. I think that should be in small letter. Objects and category, right? Now let's go ahead and run this and see. Okay, so as you can see, we have an error, and okay, they say positional argument follows keyword argument. So what am I getting wrong? Okay, I think I have to put something like this here. Now let's run that again. Boom. Now we have that figured out. So let's go ahead and check results, right? To check results, we can simply call out num underscore posts. Now let's run this. Boom. As you can see, we have all our numerical columns, all our, okay. Now, if you notice something, we were supposed to extract our numerical columns, but we ended up extracting our numerical columns, right? So we just have to go ahead and change this to cat underscore codes. So it will be for our categorical column. So as you can see, we have our categorical columns all extracted from our original data frame, which is checkup, right? Now we can go ahead and extract our numerical columns. Now to do that, we say num underscore codes is equals to checkup, right? Dot select underscore the types, okay? Then you go to include equals to, so open and close, then we'll say, so what are the types of category numerical columns we have in Python? So we just say our floats and our integer and our ints. Now let's go ahead and run this. Okay, it does not add between parentheses. Now let's run this again. Boom. Now let's go ahead and check for result. Now to check for result, we just call num underscore post, that means numerical columns. Boom. So as you can see, we have successfully extracted our numerical columns. Now we can go ahead to check for our outliers using our num underscore post. So what we have to do is checking for outliers. Now to check for outliers, we are going to visualize this using our box plots. So in other data sets we are going to be working on in this tutorial, we are also going to be checking other methods of handling outliers too and visualizing outliers. But for this particular data set, we are going to be using our box plots. Now, to check for our outliers, the first thing we have to do, let's go back to the libraries we imported. As you can see, we only imported Fibbon, right? Now, we can simply go ahead to import matplotlib. So we simply say import matplotlib dot matplotlib.pyplot, right, as plt. Now, let's go ahead and run this again. Then we can go back to this. Now, checking for outliers using box plots. To do that, we go ahead and say the first thing we have to do is we have imported matplotlib already. So we just go ahead and set our figure size, and doing that, we use plt.figure, right? Then we say fixed size should be, what fixed size should we use? So we can simply use, let's use 12. We can adjust it as needed, 12 by 61, right? Now we just have to close this too. Now the next thing we have to do is let's create our box plot, create box plots, right? Now to do that, we simply say norm underscore cos, which is our data frame we are working with. So dot box plot, right? So rotation, now what am I doing? Dot box plot. Then let's keep our rotation as 45 as usual. So we can simply add our title, right? Now to add title, we simply say plt.title. Then what should we use? We can simply say box plots of numerical columns, box plots for outliers. So this should be a string, box plots for outliers detection, right? Now, the next thing we have to do is we have to go ahead and show it. So to show our data, our visual, we just use show plt.show. So plt.show, right? Now we can simply go ahead and to ensure that our diagram doesn't go moving around, we can just tighten our layout, right? Now let's go ahead and run this. Okay, nice. Okay, title. Run this again. I think this is becoming, it's looking too big for me. So let's just say it's okay. We use 12 by 61, quite big. So we just change it to 6 instead. Now this is our box plot, right? This is our box plot. But I don't really like the way this box plot is looking. So there's something I want to do. I want to visualize this I want to visualize this box plot as a subplot. So each of the numerical column, we have its own box plot, right? So this will actually help us clearly see the outliers we have for each columns, right? So we just have to create a subplot to visualize the box plot. Creating a subplot, right? To visualize outliers with box plot. So to actually create this subplot, it's going to be a long code. So I'm just going to fast forward the video. So we just simply go ahead. So this is the code. So this is the code we are going to be making use of. So all we just have to go do is go ahead and run this code. So once we've run this code, as you can see, that we have actually successfully created our box plot. So now, as you can see, we have actually plotted a subplot or box plot to actually show if we have outliers in our codes, right? Now, when you look at box plot for dependence, you can see that we have no outliers here, right? Now, when you look at box plot of applicant income, you see that we have outliers here. So there are outliers here. We have outliers here also. We have outliers here, and we also have outliers here, and we have outliers here, right? We have outlier and an outlier here, right? Now, the next thing we have to do is we have to go ahead and handle the outliers. Now, in Python, there are various ways we can actually handle outliers. We are not going to handle our outliers. What we are going to do, we are just going to cap it, right? Now, when you cap outliers, you do not eliminate them, right? You just them, just like the name implies, you cap them to ensure that they do not actually affect your analysis. In a case where you want to actually go ahead and do your exploratory analysis, so you cap them, right? When you're capping them or winsorizing them, you're not eliminating them. You're just trying to like break their wings to make sure that they do not affect your analysis in any way. Now, to do that, we need to import another package, another library. Now, let's just go up here. To import the library, let's just go up here and note that we can simply come here and actually import the library, right? Or we can just go up there to actually ensure that everything is arranged. You can simply come up here and import it. Now, the library we are going to be importing is the visualize, right? Now, to import that library, we are going to be importing that library from a Python library we call SciPy. Now, to do that, we say from SciPy, I think I already have SciPy maybe installed. So we say from skypi.stats.mstats to import Windows. Now let's go ahead and run this. Okay, it's telling me cannot import Windows. Okay, let's know why that is happening. From SciPy dot stats dot mstats import Windows. Okay, so I think we made a mistake in the spelling, so it should be visualize, right? What's visualize? Now let's go ahead and run this again. So we have successfully imported that, right? Now the next thing we have to do is we actually have to go ahead and tap our outliers or visualize our outliers. Now to do that, we are going to be using a code. So this is quite a long code. So I'll just be writing it out and pasting it here, right, to make this a bit faster. Okay, so this is the code we are going to be using for this, right? So what we just did here is we just had to set the limit, right? Then we created a variable, right, a data frame to actually hold the visualized columns, right? Then this is us applying visualization to all the columns. Now let's just do, let me just put definitions to this. So let's say creating visualized boundary. Now, what you need to understand is this is flexible, right? You can actually use whichever limit you want on this. So it is flexible. So this is the upper boundary, and this is the upper boundary, and this is the lower boundary, right? Just remember when we maybe if you actually go the statistics, you can remember when we are just doing class boundary, right? When we have the lower boundary and the upper boundary, when we are dealing with is it input data. So this is just something similar we are actually doing here. Then the next thing is let's just say here we created a data frame, or we visualize columns. Then this is where we apply to the data frame, apply the visualization, applying visualization, right? Now, once we go ahead and run this, once once we go ahead and run this, right? Now from here you can actually see that our outliers has been tracked, right? So we have come to the end of this particular data cleaning for this particular data set. Our number one data set, 4 more to go. So let's just go ahead and look at what we did from the beginning to the start. Now the first thing we did was importing our necessary libraries here. Then we imported our data sets, right? We called our data set setup, right? Then this is us doing investigation into our data sets where we look for the first 5 rows, right? So this is us doing data investigation where we look for the first 5 rows of our data using dot head, right? Using dot head, so we are able to see the different columns that we have and also get a sneak peek into our rows. Now we also look for the last columns, right? Last 5 columns, where we noticed here that we had an issue in with three plus, right? Now the next thing we did was get more information on our data set where we try to know how many total entries we should be expecting and also try to determine the data types of our data of our columns and also try to determine if we have missing values. Now, this is where we got statistical information on our data set. Remember, we are still in the data investigation process. Now, this is actually where we checked for our missing values, where we saw that we have several missing values in several columns. Now, this is us visualizing our missing values using MSNO missing null. This is where we started our data cleaning. This is just us checking our data sets. Now, this is us renaming our data set to ensure consistency. Now, this is where we check the results after renaming our data sets. Now, this is where we also check for our missing values. Then this is where we handled our missing values using BFI and LFI method. Now, this is us checking for the results of our missing values after handling them. It was successfully handled. This is where we also got where we also did getting more info on our data set. Then this is where we checked our data set to go ahead and handle our so go ahead and change our data type into the appropriate data type. We did value count for dependents. As you can see, we have this thread plus. Then this is where we started eliminating the non-numerical column thread plus. We use it dot replace to replace thread plus with thread. Then we change the data type with to integer. Then we confirm the results, which shows here that it has been done. Then we went ahead to start handling our outliers. But before we went to handle our outliers, we extracted our numerical and our categorical columns. So this is just extracting our categorical columns, which is our strings. So we extracted our categorical columns, then we extracted our numerical columns here. Then this is us visualizing our outliers. We visualize our outliers here. But we also went ahead to visualize it as a box plot. This is what we call a box plot, where we visualize each row, where we visualize each column of the data set, right? Now, this is a box plot visualizing all our numerical columns to detect outliers. We were able to detect outliers in 5 of the columns, then we went ahead to pack our outliers.